Hi, my name is Aaron Pastor, and again, I'm a project engineer in the design lab at RPI. Um, as Kelly said, we're a program at RPI to connect students with companies and entrepreneurs, to provide a real-world experience solving an actual problem, so that they can apply everything they've learned in school to something and kind of get a taste of what it's going to be like when they graduate. So for the students, we're letting them practice the real-world engineering that they've spent 16 years in school mastering the skills for. And for sponsors, we're giving them innovative ideas and practical solutions. And we also do a pretty good job placing those students with the various companies upon graduation. Our program was founded in 2000. And in that time, we've had about 11,000 students come through. Right now, based on RPI's enrollment, we've got about 500 students a semester coming through. And we've worked on about 350 sponsored projects from entrepreneurs and outside companies, people as big as GE, people as small as Janus, entrepreneurs just have their own little idea, not a little idea, individual, smaller people. We've done about 150 community-based projects for not-for-profits in the area. And we've generated at least 7 patents. There's a couple that are pending right now. And I'm sure that there's some companies we work with that went on to patent that work that we just aren't aware of. And again, we've had dozens of direct hires from students in these companies. Kind of take a look at the product life cycle. We pretty much do everything. The professors on campus handle research, but once those ideas begin, our projects expand the gamut from everything from development, product development, manufacturing, helping on the manufacturing level to improve factories, process flow, developing test equipment for new ideas, and just I'll go through a number of examples we've done. We had a project a while back for a major car company. They were looking for ideas that Generation Y would want to see in a car. So the students came up with a bunch of ideas, developed the technology behind that, and kind of help them to get an insight into that market. We've done proof of concept ideas, proof of concept projects for companies. They've got an idea, they may not have the resources to devote their in-house engineering staff to do, or something that's kind of out there. They're interested in looking at. So we did some 3D printing for somebody. It was probably about 5 years ago. Revit was starting to come into focus as a new technology. And we added some new materials to that to see what we can do with that. We had a project for GE actually looking at de-icing material. Obviously you heated stuff up in your microwave and heated it up and melted it. You've been on an airplane and seen them spray de-icing fluid over everything to get rid of the ice. We were looking at could we marry those two things together and use a microwave to heat up a large component and get rid of the ice. So we did some initial work. Students basically took a microwave oven, ripped the guts out, did a fair amount of testing. You can see we were able to generate heat in just that one area, and kind of prove that that was a viable concept. And then GE went on to try to use that idea. We've done a fair number of projects on initial product development, similar to what Janice was working on. She spoke about with the nitrogen filling. Actually, the aircraft wiring clamp. That entrepreneur is going to present, I believe, at the next Fuse Hub meeting, talking about his idea. But after he thought of it in a course at RPI, he came to the design lab, and we brought that idea farther, did a fair amount of analysis to fully flesh out the idea, do some engineering behind it to see if it was strong enough, if it was going to break. And we have access to a pretty extensive suite of software that students can use that may not be available to everybody else out there in the world. And they were able to do a lot of analysis there to see, is a bendable clamp there, looked at whether that was a good idea, how thick and strong they needed to be to resist the forces it was going to be under. We developed a children's bath toy for another sponsor, just fleshing out that full idea, generating some CAD designs, understanding how those would get manufactured through injection molding and assembly and how that would all go together, so they did some good manufacturing work for that. We've done a fair number of software-based projects. Just a project, the students built a robot, but really the core of the project was developing the path planning and sensors that robot would need to safely navigate a unknown building layout. It could go and sense what was going on, detect the walls, go and take some sensor readings for various things that the sponsor was interested in, then report all that back. And the goal was to replace a team of installation technicians who basically walked around, can you hear me now, can you hear me now, testing for days. They built a robot to kind of automate all that, do it 24/7 and get the results much faster. We did a project to enable you to take a picture of a sign or a font or something like that and identify what that font was, look through the list of all the available choices from a font, I was going to say manufacturer, but I'm not sure what the designer is. Font designer, be able to recommend, oh, you like that font here, we can sell you this one or this one, which looks similar to that. It's kind of a classification algorithm. We've done a fair number of test equipment projects. So this was, currently working on this one for an aircraft manufacturer. The way they currently test new designs and geometries is they build a model, put it in the wind tunnel, fire up the wind, take a bunch of measurements, shut it down, open the thing up, move one component a little bit, close it up, turn it back on, test it all again. And they said this is taking us forever. So students have worked on automating or remote controlling that system, little motors and stuff in there to move it around, but taking into account all the forces and doing that design work. So what we've offered to sponsors is access to top students and looking to solve their problems, putting together all they've learned through their coursework. We have a somewhat unique agreement in RPI that the sponsor retains the ownership of all the intellectual property. So whether that's a patent, as I said, we've generated about at least 7 patents. RPI doesn't own those patents. The students don't own those patents. The sponsor company owns those patents. So I happen to have my name on, I think, 3. I don't own anything. Sponsor has that because they sponsor the project. But whoever's appropriately listed on there as the vendors is there. So you maintain that intellectual property. You get access to the facilities we have on campus. We have machinists on staff, machine things. We've got access to all the resources on campus. There's test equipment and software and computers. Talk to professors that are experts in their field on various things. They're always happy to help out the students on a project. And fundamentally, we just offer low-cost engineering support to various companies and businesses and entrepreneurs. So I don't really have an ask. We want to offer you help with your problems. We've got students every semester. We get about 250 of them. They have all this knowledge, and they need to work on a capstone experience to get their degree. So we're just looking to help people out. So please come and talk to me. I've got some brochures over here describing the last 2 years' worth of projects we've done. And we just we're looking for problems, and we'll help you solve them. Questions?
Tell me a little bit about the students that make up the teams.
So our teams are typically 6 to 8 students. They get an engineer like myself and a professor to help them mentor them through the process. And we are a required course for every mechanical engineer, industrial engineer, materials engineer, computer systems engineer, and electrical engineer. So roughly, again, 500 students a semester, and they're all required to take our course, so we get all of them. We do get a small percentage of biomedical, aeronautical, and civil, or primarily civil. So most projects we're able to scope out some aspect of that we can really apply their knowledge to. Thank you very much.